Well, I've been looking for these for a while, and there's two types. The type that are listed for a reasonable price, and by the time you message the guy, it's already sold. And then there's the other type that's out there for $3,500, and it burns oil because it's got so many hours on it. So I finally was the first one to message the guy, and you'll never guess what I paid for this thing. $350 delivered. However, of course, we don't know if it runs and if it'll weld, most importantly. So my name's Tyler, you guys are watching Diesel, and we need one of these things to do some work in the field. So we're gonna fix it up. Let's get into it. All right, so here's the point of the video where you might be saying, what is this thing and why do you need it, Tyler? Totally legitimate question. My wife asked the same thing when she came home and it was sitting in the garage in her parking spot. So we all love welding, right? We use welding for the manufacture of goods, repair, construction. Well, welding takes a lot of power. This is my 250 amp Miller wire welder, and it's got a special plug, 240, which you don't have everywhere. Not even every garage has that. And this thing is tapped out 50 amps, which is about 12,000 watts. That's a lot of power to take on the go. That's a lot of power even for a lot of people's like personal dwellings, like a garage like this. So what Miller did was they basically just took a home backup generator and they put a bit of a special stator, I guess it is a special stator in it, and it's got some extra taps. So this will produce both like, AC wall power that you get from an outlet, but it'll also produce AC, DC, constant, I believe, power and constant voltage welding current too, right? Of all of the different varieties. So this thing will actually do 225 amps of welding. So it'll do about the same thickness as my MIG welder over there. It's totally portable. It's on the go, and you can do MIG, TIG, stick, AC, aluminum, steel, whatever you want with this thing, right? So they're pretty awesome. And honestly, it's like the only good way to weld on the go, just because a big old dinosaur like that takes so much power. And Miller makes a ton of these. They made them pretty economical. So that's what this is. It is a portable welder that allows you to do big jobs wherever you want because it's all contained, right? But then when your wife asks you why you need one, you say, honey, it's a home backup generator so that when the power goes out, we can still run the furnace, the fridge, and make coffee in the morning, things like that. So that is why you need one. Surprisingly, it's dirty. The transformer might be bouncing around down there or whatever that is. But surprisingly, it kind of looks complete. Unscrew that for me.
Now you turn now.
Oh, you want to have a turn? Okay. No, right here. There you go.
Don't tie.
Let's loosen it. Good job, keep going. Good job, look at that. Oop. I think I gotta take this manifold off. And then the whole top comes off. And then I can take the carburetor off from the bottom. Well, I don't know if I want to go all in on the carb, but I guess I might need to. Oh. Oh, it just fell out. Honestly, does not look bad at all. I kind of wonder. Just waiting for my carb kit. Man, not even a honk today? Here, you want this? Oh, that actually looks like brand new, Luke.
No.
Hey, how'd that old spark plug get in there? Did someone put it down that hole? Huh. Now we gotta get it out. I had to take that off. What did we learn? Nothing. We're probably gonna put more stuff down. All right, I wanna put some WD in these cylinders and roll it over because I don't know how long it's been since it's rolled over. We can see if it rolls over, see how it sounds. We can see if the hour meter works to see if that even is remotely right. Well, that's a bummer. At this point in time, I would say the hour meter doesn't work. Oh, I just heard the hour meter click. The hour meter must be oil pressure based because now I hear it clicking a ton. Well, I'm not sure if this is kosher, but I want to put just a little bit of anti-seize on these things. Oh yeah, look at that. It's got a great spark. This thing might be a runner. We gotta get that carburetor back together. Yeah, and this one, it looks good that way if you rotate it. If you rotate it 180, it doesn't work. So you got the bad side to the inside. It's okay. Should be okay. Let's put some gas in it, Luke. Looks like it's bone dry. Hey, don't smell that. All right, can you put the lid on? Oh, that's a good sign. Battery being dead is not a good sign. All right, we have fuel. We also have a little bit of junk, so I guess let me take the spark plugs out maybe. Then I can roll it over a little better and let me get that battery on the charge. It's a little milky. It's not the best gas I've ever seen in the world, but no more junk was coming out, so I don't think I'm gonna plug up the carburetor at least. Want some more? Seems like it was revving a little high.
Want some more?
You want some more? Mm-hmm. I'll have to fix that, but look at that.
You want some more?
Okay, we'll start up in a second. See that's this right here is like a solenoid for idle. And it was like this. It was clipped up over there. So the throttle, see that's idle. The throttle couldn't come back. All right, let's try it again, Luke. It's gonna work. Sounds good. Sounds really good. So it's got a run and a run idle. That's the idle position, it idles it down. And I think when you're welding and you strike an arc, it'll automatically go back up. Well, what do you think?
It was.
You want some more? It seems to run really good. I mean, I don't think it's burning any oil. I mean, it could be. Ooh, we gotta be careful with that. No, I really don't. I think. Yeah, don't touch that, buddy. I think if it says 700 hours, it legit is 700 hours. It's making 130 volts. Really? So I think we gotta adjust maybe the RPMs down a little bit. I'm pumped. I mean, for 350 bucks, I don't think you can do any better than that. I just have my hands full right now. Okay, but we gotta get all these rascals inside. High five. It runs, yeah. I think it was time for a new air filter. I would say yes. So we got between 70 and 150, so that's a range of 80. So 5 would be 40, so that'd be right at like 110. Maybe we'll go down a little bit. It like doesn't have the power to sustain an arc. I'm not sure what the deal is. And I mean, I had it set pretty hot too. I'm not convinced it was anything with that. I don't know, you know, maybe I need to clean the controls. I know that's the first thing Aiden would do. Hey, definitely Not the welder that I was hoping it would be. Damn. Now there's a chance. There's a chance that I'm just a really bad welder. I'm going to blame it on the machine for now. All right, so before we get lost in the universe of troubleshooting, basically what's under the cover there, maybe we should understand a little bit about how they work, right? So there's three main components in this device electrically. There's a stator, so this is where the stuff comes from. There's a rotor that spins inside of here. That's attached to the engine. That's the only part that spins. And that induces the magnetic field or produces a magnetic field that, acts upon the stator. And then you also have, in order to induce the magnetic field in the rotor, you have an excitation circuit. So you have, essentially kind of like a feedback loop that's initially fed from the battery. And what that does is that inputs a certain amount of current into this rotor. And then from Faraday's law, the strength of this magnetic field is dependent upon the amperes that go into it, right? So our engine RPM is fixed at 60 hertz, 3,600 RPMs. You could take this apart and rewind it to have it do different things, but this is not going to change, right? So if I plug in a 10 watt load or a 10,000 watt load for this device, the only thing that can change is the strength of this revolving field, which is what we need to change in order to make the proper amount of current that either our weld or our devices are demanding. And the only way that this can change is by this excitation voltage. Well, that didn't work. It's still the same. The only other thing it could be in my mind without diving super deep is just the field coil brushes there. And now we know why it was cheap. Another thing is, too, I did accidentally try it in AC. Right now I should be in DC plus. That's AC. I did try in AC and it didn't work. I tried it there, it didn't work. Tried this in different positions. The only reason I say AC is because I'm guessing, I don't know, I'm guessing this thing puts out straight AC, and then this happens to make it DC. So if this was bad but this was good, then I could see the AC working, but I don't think that's the case. Shoot. I'm going to have a lot of reading to do, I think. Oh boy. I never really looked. I mean, I could kind of tell it was rusty down there, but I never really looked. But that thing, I don't know what that is, but that's not good. All right, so this is a resistor. This is fine. And then that's a bridge rectifier, and that's a diode, I think. This one I'm not entirely sure how to measure, but this one's giving me voltage the same way back and forth. So I do think that diode's bad. I'll double check how to check it. Maybe we'll start there. And then I also want to just start it up and put it under a heavy AC load and see if it works. I checked pretty much everything else out that I understand. I don't see any concerns, but I think a lot of the tests that we got to do are kind of with it running. This is that diode that I'm thinking is bad. So it does directly feed our excitation, All right, so a couple of things. First thing it says, well, I'm reading on forums. It says when it's on, which I'm not sure. It might need to see oil pressure or something. We should be getting 12 volts across the exciter circuit from the battery. And we're not, but I don't hear my hour meter clicking either, so. See, the hour meter's clicking now, so I'm only getting 4 volts there across the exciter circuit. So that's number 1. Number 2, they said you gotta check this diode alone. Do we still get stuff back and forth? Looks like no, I'm getting open line that way. But why am I only getting 0.4 volts to my exciter circuit? Or 4 volts to my exciter circuit? All right, I tested it. Basically, you just go positive to negative, and it should pass. So it's like 0.2 to 0.9 volts on the diode reading on a multimeter. And then you go positive to negative shouldn't. Positive to negative pass. Positive to negative shouldn't. So you just work your way around counterclockwise. And this one checks out good, so. All right, we got to put our headphones on, right? But I have ohmed out my welding leads to the work part. I have ohmed out the cables, you know, the connections I did there. I've ohmed out my resistor. I checked my capacitor. I checked all my diodes. I checked my brushes, made sure those were not stuck. I've essentially checked everything, I think, except for this is a big rectifier, I think. Hey, no, Luke, no. We shouldn't just plug stuff in. This, which I think is a big rectifier, and then these 2 items down there. I haven't checked those. So what I want to do, I want to start up and I want to put it under a good AC load. And what that'll tell me is if the actual generator part is getting excited and outputting the proper current. And then everything else that's welding related would be those 3 devices down there. So that's what we're going to do. So I'm only getting 90 volts right now. It sounds like it's idle and low. 100 volts. So we'll have to check that. But that's enough to where I know it's being excited. Now under a load. I can hear it loading it. Yeah, 87 volts. So at this point I would say I'm getting excitation. Not perfect. Oh, gotta have that all the way up. I feel like someone turned that knob on. No. Yeah, I'm getting 100 volts. My RPMs are just a little off, but I do think it's producing an 8. All right, so I found another thread online. And the guy had kind of similar stuff. But what happened was his ballast resistor was just reading a little bit high. So he had maybe 10 ohms or so, let's say, through his excitation circuit. So this is 5. Then if I measure down here across the coils or the slip rings on here, we have 3.2, 3.3. So we should have 8.3 ohms total. So if I plug this in, and I go 3 my resistor to ground, we have 5.1 just through the rotor, and then it's plus 5 on this side. So we have 10.3, 10.2, and we are supposed to have, 8.3? So we have 2 ohms extra. And in that thread, his ballast resistor was reading 7 ohms instead of 5, and that was given in the exact same fits as what we have. So if we dig a little further, we measured that unit down there, the rotor, and that was right, about 3.3. So if I measure through the brushes, I don't get 3.3. I get an extra 2 ohms resistance, right? So if I go further, then I measure from one brush to its slip ring, I get 0 ohms. And from the other brush to its slip ring, I get 1.6, which could be my extra resistance. See, we measured 3.3 through the rotor. Now I'm getting 5 ohms here. So that definitely could be our issue. Is that true? 0 ohms there, 0 ohms there. Oh no, it's coming up. Wow. Why so much resistance through that one? And not this one. So I got some parts. I got a brush and brush holder. I did get the bridge rectifier and the other diode, just because I guess they're problematic and they go bad. But don't worry, we won't install those. We'll do one at a time until we know. And then I got the capacitor too. So I was talking with AH Fix It, and we probably didn't need to buy this. This specific Miller one for $100, but whatever. I'm not trying to cut corners on this thing. So let's, like I said, I want to try one at a time. So let's try, I don't even know what they're barking at. Nothing. Try this first, and we'll see, because I think this is the root of our problem. And then we'll throw the cap in. Alright, so now we can check this circuit and see what we're getting. It should be like 3.3 ohms or something across here. 4.1. Still higher than what I wanted. That's better. Just gotta run them in. I'm sure they'll run in pretty quick. So, all right, I think we should try it and see what we get. All right, so the plus side, see all those little, there's like a line of pluses there. I think you got to make sure you get those right. Well, actually, let's measure this first, just to see what the system says about it. So maybe it wasn't bad, because maybe my meter doesn't know how to read this. 3.971 nano. I guess I have it on the wrong side. Well, it definitely reads different than the old one. But looking at this, I would say that this meter is not competent at measuring capacitance, which is kind of a bummer. I mean, it definitely reads more than the old one, so I don't know. All right, it's in. I mean, it just doesn't have the balls to keep a stick going. And I don't think, there's a possibility, but I don't think it's because I'm a bad welder. Well, as usual, I don't have a firm answer. I literally haven't done anything since the last time I showed you guys something except for one thing. I still don't know where my wife and kid went. I thought they would want to hear me engine weld. I'll tell you what. You're right. I'll let some heat in her. She's burned 3 rods. Tried a 7018, but I think that's just hard. So I made a little video asking you guys for help, because that's what I always do. And someone said, make sure that your 12-volt charging circuit is working, because if you don't have a solid 12 volts here, it won't have enough to energize the coil and the field will collapse. So I charged the battery. Actually, what happened, this is kind of funny, Luke comes over and turns the key all the time. He turned the key on and left it on. So I charged the battery and then said, well, it's like 13.5 volts right now, not 14.5. I said, well, I'll try and weld with it. And what I did first was I checked the open currents and outlet voltage, and everything actually looked right in line. I got that 5 volts I needed. So I said, well, let me try and burn a rod with it. And it works. So I'm still not happy. It seemed to bog when I'm welding with it. I'm still not happy with that, and then I want it to charge. So let's make it charge first and then figure out what's going on with our governor there. All right, so to check the charging system, there's 2 AC wires coming out of the alternator behind the flywheel, and then I believe there's 1 DC wire coming off of this rectifier. So I know one thing, sometimes the magnets on these get stuck. So the magnets are glued to the flywheel, and sometimes they come off the flywheel and get stuck to the stator. I can see the magnets are spinning, so that's good news. So we dodged a bullet there. So the next thing is to check, I believe it's the 2 outside wires in this one. We can just make sure our stator isn't burnt. Yeah, so I got 0 ohms across it, that's good. So we should have 60 volts AC when that's running across those 2 terminals. All right, that is about as good a news as you can get. You want it on? That's about as good a news as you can get with these things.
Hi, Dada.
Hi, buddy.
Hi, Dada.
We'll turn it on in a minute. We gotta fix it so it charges. So that means, likely, that the voltage regulator is bad. All right, let's put on our headphones, because we're gonna start it up again. Well, unfortunately, it's still not charging. What's going on? All right, so I got this out. And I read this, and this is exactly what I thought, but then I found something else out. That regulator has to be grounded to the body, otherwise it won't work. So let's try it again. Well, she was charging because I nuked my cables. I think it was putting that much voltage at it, which is actually pretty hilarious. I wouldn't say it's charging a ton, but it's definitely charging. I think that's right. I could maybe not have the best ground, so maybe I'll do another ground for that, but it's charging. I'm confident she's okay. All right, so it has been, I think the last time maybe I worked on this was like, let's say May or June, and it's now mid-October. Obviously, just as everything, it's gotten pushed away for other projects. Got the E50 out of here. We got the Liebherr wrapped up. Working on 977 stuff now. But if you guys ever drop something off at a shop and it ended up taking a really long time, it's not because it takes a long time to do it. It's just because they're not working on it. And my customer, my dad, is calling me saying, hey, he's got an irrigation pump we're adding this year, and it's all steel piping. We already welded one part in. That was in the Liebherr video up here I'll put. And we struggle to find a generator welder. So we need one kind of, so we got to get back into it. But the problem is I don't really remember where I left off. So I checked the video and it looks like where we left off was I kind of got it to weld okay. But a couple things, I think it's still dropping engine RPM a little bit, but I don't know. We'll decouple that now and separate that. The biggest thing before I start putting this machine back together and really testing it for me is just this bottom plate and potentially these two. I'd like to investigate these two a little more too. So if you look, there's nothing holding that down there. So unfortunately, I think we got to tear the entire machine down. Because I think you would build it from the bottom up. So let's try and separate that bottom pan out. You know what? Now I know why I've been delaying this, because it's a wiring nightmare. So the current sensor passing through 70. All right, so I've got 4 wires here. So I've got 153 furthest left. So I think other than cleaning this up a little bit, I think this is good. I don't think there's any issues with this. I think now we can take the motor out. So looks like a piece right there, and then maybe 2 motor mount bolts. And I'm guessing it's gonna slide that way. Let's see. You search high and low on the internet, there's not much covering these things. There's no like disassembly procedure. There's some limited troubleshooting stuff, but there's no gurus out there to help you. So that's one of the struggles with a machine like this, and that's why I hope this video is good for someone. If one person can use it, it's worth it. Go to tear something like this apart, you know, you just dive in, but see, there's some pins there. That's simple. All right, so this, although it's bad, Swiss cheese. I don't think this is a death sentence to this machine because it's just a pan. And I think I can make one up. Honestly, it'd be a super good candidate for just some CAD. Get it laser cut and fold it up, right? It's just a sheet metal bent pan. That piece looks okay. This one, I don't know. I might be able to just weld that back in or something. We'd have to see. So that's okay. But this right here, it's hard to say because the core kind of looks intact. You know, the outer layers are flaking off. And then this one the same. I mean, the bottom looks okay. I do think electrically, I mean, you're gonna lose, maybe 10% or whatever this did because of the outside. And I know the copper's okay. That's a little scary. Maybe I'd clean that out. But I kind of think electrically, those would pass. Now, obviously, if I'm this far into the machine, I'd rather try and find something. But the problem is, I've been off this job for 5 months. I've been looking. I've been looking on Marketplace. I've been looking everywhere for these parts. And I think what I've come to the conclusion is everyone in the Midwest or in the Rust Belt or whatever that has one of these or a lot of these are on the back of a service truck. They get to this point. So if there is stabilizers, reactors, which is these two parts, they're gone. You know, people don't take them. Same thing with the bottom pan. So like you'll find switches, engines, generators, all the parts above like that line, but everything below that line that just sits in the pan, it gets rusted up. Stuff's fine. So now that I know what I've got, let me look around and make some calls and see if I can find something. And if I can, awesome. If I can't, I don't know, we might have to find a part. But the problem is here in Michigan, I can't find a clean parts machine. They all look like this, you know. So I kind of knew when this showed up on the truck, I looked and I was like, yeah, let's look at the other stuff first and see. Got the other stuff working, but now this is a gut punch. This sucks. Man, that's a nice SV. We're getting rain today. It's the first time we've gotten rain in weeks. That's a nice SV100. I might have to get one of those to one-up Dad because it's probably about twice the size of his machine. So I'm down here at the Ohio-Michigan border at Buck and Navi Equipment Company. So they're, looks like a big shop. I don't know. It's a little far away from me. I've never been here. They're a dealer and whatnot, but you guys will never guess what I found. So, look at all that stuff. Man, look at those. Wow. It's like Christmas. So yesterday after my gut punch, this is a one-day turnaround on a decision like this for me. You guys would be surprised, or proud. I got online, I just searched Bobcat 225 for sale or whatever, and one with like a fried stator popped up in, I don't know where we are, New Carlisle. No, not New Carlisle, wherever this place is. It's like maybe 50, 60 miles away. And I said, you know, you guys will see it's not the same machine. I got a plan. I said, that's not bad. The guy had $1,000 on it. So I called him. And I'm like, hey, what's the story with this? What do you want for it? He said, come pick it up, $500. So I said, all right, I got to take it. So it's a super clean unit. Someone plugged something wrong in and fried the stator. But the base pan and the stabilizer and the reactor all look mint. And there's probably a ton of other good parts on it. It's got a V-twin Kohler on it. That should be good. So let's go home. Let's put it in the garage and tear it apart and see if we can take the two, make a union, and combine them into one. The guy was super nice there. But we had the awkward conversation. So what do you do? Well, I make YouTube videos, sir. You what? Here's the thing. I've been working on this for 7 months, 9 months. I don't know how long. And I think between the two, I think I'll have one good welder. I think the good welder will be this one. I think I'd be kind of a fool not to keep that. Just because, I mean, I could start it up again and weld with it. But just because I think that one welds a lot better. This one, I like this machine. I don't have that much money into it. I might have $600-700 into it total. I'll add it up for you guys. But I don't know. You know, I think I'd be a fool to get rid of that one just because I don't think it welds as good as this one. And then I don't know if I could sell this machine in good faith, to be honest with you. So maybe we should tie things out and give some closing troubleshooting, you know, I want to say like theories or whatever, just if there's some poor soul out there that's trying to diagnose one of these, what's going on and what's like the train of thought that you need to have. Because I don't know all the specs you need to check or what steps you need to do. But where can you maybe look for some issues if you have one of these that's going on? Well, the stator right here, the stator is bad. So not to say that it's totally on or off, but if you have some issues with your welding circuit and it's not producing anything, or if you kind of let the smoke out of it, if you have some issues with your AC and it's not producing anything, basically what will happen with these is the insulation, these wires are covered in varnish, the insulation will go and then you'll short to ground, or the wires will short together. And like I said, it's kind of on or it's off. So if you're getting a little bit of a trickle of AC, or you can weld a little bit, then I would say it's probably not your stator. The same I would say for your actual rotor construction. I wouldn't bother looking at that unless you see it's visibly blown, like your slip rings are worn through and you're not getting conduction between there or something. They're kind of on or they're off. Where the money's made on this thing is in this excitation circuit, because this actually is responsible for exciting the entire power generation function of the device, and then also regulating it too, right? So you see you got this extra excitation winding, and that comes into this diode, and this is actually closed loop feedback to maintain 120 volts or 240 or whatever it is, however it works, right? So generally, if you have issues, what you can do is you can ohm out essentially from your welding leads, back to like your outputs on your stator. These just come off to one of the switches. And like if you have continuity through there, then you're probably fine. If you don't have continuity through there, then maybe you burn up something in here. This, big rectifier down here, you can try welding an AC. If you can't weld an AC or DC, then you look up. But like I said, generally just quick ohm everything out, and then let's look at the excitation, right? So the excitation, there's a lot going on in here, and where I got tripped up was just that my excitation was not receiving the proper power, right? So the law of electromagnetics, or whatever you want to call it, Faraday's law, the strength of a magnetic field is a function of the current, amperes, flowing through the conductor, right? So we don't change our voltage on our rotor. We don't change the speed of the rotor and the engine. All we change is just how much current flows through that, right? Well, if you look at this, you've got brushes, you've got a resistor, you've got another resistor, you've got a diode, you've got this, you got a fuse, another plug, you've got all this stuff. And I don't know what the exact spec on ohms is, but it's pretty sensitive to that. So where I got tripped up was, I saw that I had a little bit of high ohmage right here. You should check everything else out, because like down here, we've got so much current that if you have like an extra ohm, it's probably not going to matter. But up here, we're really kind of not playing with that much sauce. So if you have an extra ohm or two, it's really going to mess you up. And it's a feedback loop, right? So if I have like an extra ohm in here, I'm not going to get that, kind of recirculation effect, or whatever you want to call it, that snowballing effect to get this thing up to where it needs to be. And then where I got tripped up is you got to have the proper excitation, like fuel or gas or pressure, whatever you want to call it. In this in electrical terms, I would say volts and amps. You got to have the correct coming from your battery. And I just never had a good battery on there, or working charging system to fire that, right? So like if we were saying we need 100 PSI from the battery to get this thing started, we might have had 57 PSI and it just never really trickled in, right? So you got to have that initial excitation voltage from the battery to get this thing fired up. So if you're troubleshooting one of these, just roughly check out your stator and your rotor, make sure that they're not burnt, measure the continuity on the slip rings and stuff, measure the taps on your stator. And then beyond that, you really got to go into, and it's easy to check because you can check it right there at the slip rings on the rotor, right? You got to go into what is my ohmage through here and am I getting the proper voltage and stuff like that. And once you get that, they're pretty bulletproof. But that's kind of where, in my opinion, this is a year removed from initially buying the welder. That's where you kind of want to look for the stuff on these that's a little funky or niche or maybe hard to understand is what I would say, but focus there, focus in on that excitation circuit. And then if that's fine, then you can maybe look for some higher ohmage throughout the rest of the device, but I doubt you actually have that. It's either burnt or not burnt generally.